Hi everyone. Today we discuss about the one gate question from gate 2020, question number 29. So this is spectroscopy question. A compound with molecular formula C10H12O2 showed a strong IR band at 70-20 centimeter inverse and a mass peak M by Z 122 in the mass spectrum, and the following one is signal at delta equals to 8.1 to 8.0, 2 hydrogen multiplet, 7.6 to 7.5, 1 hydrogen multiplet, 7.5 to 7.3, 2 hydrogen multiplet, and 4.3 delta, 2 hydrogen triplet, 1.8 delta, 2 hydrogen sextet, and 1.0, 3 hydrogen triplet. 3 hydrogen triplet. The structure of the following compound is, there is the four options. So we have to find. Let's say this is the IR value. So from the IR value, first we try to predict, try to neglect two, three options. From the mass also we try to neglect two, three options. Then we'll say the NMR, what is the true answer. So this acid normally shows the IR at 1710 centimeter inverse. This type of ester, say this is the pure ester and this is the conjugated ester. Normally this type of ester will show the value at 1745 centimeter inverse. But this is conjugated ester, right? That's why due to this conjugation, this double bond becomes sometimes single bond character, right? That's why its value will be somewhat less, maybe 70-20 centimeter inverse. Let's try to think. And this is ketone and conjugated ketone. That's why its value will be little less, around 710. Okay, so the these three value are nearly close. Okay, so that is one indication. So we can neglect this option, option C. Okay, so now come to the another thing. What is the value of this benzene ring? Normally, the delta value in 1H, the delta will be normally 7.2 ppm. If one electron donating group is present, this orthoproton delta value will be around 6.9 ppm. Okay, that is one thing, because due to this conjugation, the electron density will increase here, right? That's why it will be more sealed and the delta value will be 6.9 ppm. But in the case of electron withdrawing group like ketone ester, this type of conjugation is there, right? That's why one positive charge will come and this ring becomes electron deficient. That time the delta value will be around 6.6 ppm. So if the electron donating group is present, the delta value will be somewhat less, and if the electron withdrawing group present, the delta value will be somewhat above than 7.2. That is the main thing. So now come to the question. So in this question we already neglect option C, right? So now the thing is that it shows 8.1, 7.6 and 7.5. I means all are above 7.2. That means there should be one electron withdrawing group present. So let's see why electron withdrawing group present. There is also present, here is also present, and here is also present. Right? So that is fine. Let's see that is okay. And this 1 to 2 peaks. This 1 to 2 peaks is basically due to this. If you try to calculate, you will get this 1 to 2 peaks basically due to this benzoic acid peak. So in this case, if we try to break like this is normally abnormal type of break. So this never will show 122 peaks. So we almost can neglect this one. Okay. And in this case, here OH will be there. We can also neglect. Okay. But now come to the most important thing, that is the NMR. So it shows two hydrogen triplet. What is the meaning of that? Two hydrogen triplet mean there will be one CH2 moiety, right? That will attach to one CH2 moiety. That's why this hydrogen will show, and here will be no hydrogen in this corresponding X, something here. So this hydrogen will show two hydrogen triplet, right? And the next thing is showing the two hydrogen sextet. That means there will be CH2, one side will be CH2 and another side will be CH3. And another thing is that 1.03 hydrogen triplet. That means there will be CH3 and CH2. So if we add these things, so we will get basically CH2, CH2, CH3. So here also same thing present CH2, CH2, CH3. Here is also present CH2, CH2, CH3. Now the what answer is correct? The correct answer will be this one, because see, this is 4.32 hydrogen triplet. Due to the ester group, this hydrogen will be most resilient, but due to the aromatic ring, this hydrogen that will not be that much sealed. That will be around 2, 2.3. But due to this is the one important thing to remember. If the ester group is there, the next carbon will go around 4.1 to 4.3. So that's why the correct structure will be our B. So this is our correct structure. Okay. So to know more, you can see this NPTEL video. Thank you.